So let's start with today's topic, like schema. Okay, so schema, like it is used in the, you can say, basically schema is something which defines how is the architecture of particular, we can say, database. Okay, so here basically most important three schemas are there. Like first one is like star, second one is the snowflake, and the third one, which is FC FCS, that is the fact constellation schema, we can say, right? So over here, like, let's start with the star schema. So star schema will basically look like a star, like this. So what's here, like basically we have a structure like this. We may have like this, fact table and associated dimension tables like D1, we can say D2, D3, and the last one we can say is a D4. Okay, so here, like if we go for the overall architecture of this schema, it looks like, we can say star. Right here, you might have seen this is the fact table. Okay, and yes, and we are having a schema. We are having a schema like a star. This is forming a pattern like a star, right? So that's why it is considered as the star schema. Basically, star schema is having the structure like we can say star, but one thing to note here is like let me, it will be easy for you also to view this, right? Okay, so here how you can identify whether it is a star schema. In the star schema, the fact table which is given is in the normalized form. Basically, you might have heard about the normalization, right? It has the 6 normalized forms, like starting from 1, 2, 3, 4, 5, and 6. Okay, so these are the normalized forms. Okay, it will be covered in another lecture, but yeah, it is important to know, like, the fact table has to be in we can say normalized form. But if you go for the dimension tables, those are denormalized forms. Okay, and yeah, so this is the overall we can say about the star schema. If you go for the snowflake, right, so here we consider the snowflake. So in the snowflake, what happens is like we can see a star schema is equal to snowflake schema, but there is a condition, that is the star schema, if the star schema, okay, in the star schema, if in the star schema, if all the dimension tables that are given, okay, all the dimensions or dimension tables given, those are normalized. Okay, then only we can consider this as a snowflake schema. So star schema could be a snowflake schema, but there is a condition, that is the dimension tables which given in the basically the star schema having the dimension tables in the denormalized form, right? But whereas in the Snowflake, the dimension tables has to be in the normalized form. Like let us say we have the fact table, right? And we might have dimension tables like D1. This dimension table might have another dimension table which is called as suppose D4. If you go for the D, we have another dimension table like D5. It might have another dimension table D6. So overall architecture would be like a Snowflake one. Okay, here basically Snowflake is used to manage the size of the dimension tables, right? For that purpose we use the Snowflake. So in the Snowflake, what happens? The dimension tables given, those should be in the normalized form. What do you understand the normalized form? Like dimension table may have another dimension table too. Okay, so this is the Snowflake schema. And if we go for the last one, that is the FCS, that is the fact constellation schema. So here what happens is we have let's say a fact table and we have some dimension tables. Okay, and here these dimension tables may be maybe the dimension tables for another fact table. F1 say fact table, this is the second fact table F2. So overall architecture would be like it has more than one fact tables sharing the same dimension tables between them. So basically it is a complicated and complex ones. The design part is complicated and the complex one because of this sharing of the dimension table between the two fact tables or more than two fact tables. So that's why it is called as a fact constellation schema. Okay, so yeah, these are the main we can say schemas in the database system. Okay, thank you guys, see you in the next video.